So originally this was day one of exploring transformations, but I feel like this is the most easy to teach two-dimensionally. I don't necessarily think this is easy, but I think it's the easiest to teach two-dimensionally. So I want you to see that here's the graph, and then here's a table written in function notation. So what it really means, if I was to write it like this, is negative 2, 1, negative 1, negative 1, 0, 2, 1, 1, 2, 3, and 3, 0. And if you look, there's 1, 1, there's 3, 0. So here's all those points written over there. So what I want you to do is this is the original function, and we're always going to go back to the original, always the original. What they're asking you to do is take that original x, and they want you to add 2. So here's this x right here, and they want you to plug it in, and you would go, in a sense, it's negative 4 plus 2. Negative 4 plus 2 is negative 2. So they're asking you to find f of negative 2. Well, if I look over here, f of negative 2 is 1. Just trust me on this, and I promise it'll make sense. So if I plug in f of negative 3, it's f of negative 3 plus 2. Negative 3 plus 2 is negative 1. So what's f of negative 1? Negative 1. That's the y value. Do the same thing. Negative 2 plus 2 is 0. The y value is 2. Negative 1 plus 2 is 1. The y value is 1. If I have 0, and I go 0 plus 2 is 2, and f of 2 is 3, and then 0. So what does this mean? Well, let's say I graphed this on here. So I would go left 4, 1, 2, 3, 4, up 1. I would go left 3, down 1. I would go left 2, up 2. And then left 1, up 1. And then 0, 3. And then 1, 0. So if I connected these, this shape is the same thing as this shape. If you look at the start, though, the start moved to this way. Look at the end. The end moved to this way. This top moved to this way. So what this is telling you is that it is a vertical translation to units left, which you learned that before, that when it says plus 2, it's not with the x, it's not a straight shooter. So that means it's going to be the opposite. So if you were to do this one, and this is minus 2, you know minus 2 really means plus 2. And by vertical, I mean horizontal. I'm so sorry. Horizontal translation 2 units left. So this would be a horizontal translation 2 units right. So what does that mean for the y values? So if I had an x was 0, 0 minus 2 is negative 2, 1. 1 minus 2 is negative 1, negative 1. Same thing all the way down. If you get it, you can just pause this at any time. But remember, I want you to see what's the transformation and what are the new x values that still give me the same y value. So if you notice, the height is still the same, but it just shifts left or right. Okay? Now I want you to look at this one. This is where it gets a little bit more difficult. Now what I'm saying is the 2 isn't with the x, it's with the y. So you know it's going to be, because you've already learned it because we jumped ahead, vertical translation 2 units up. But what does that mean for these y values? What we're saying is that if you plug in f of negative 2, so let me put that in pen, f of negative 2, you get 1. But then I want you to add 2 to it, and that's 3. F of negative 1 is negative 1, plus 2 is 1. And I'll show you this visually. F of 0 is 2, but I add 2, 4. F of 1 is 1, I add 2, that's 3. F of 2 is 3, plus 2 is 5. F of 3 is 0, plus 2 is 2. So if I was to graph this, let me show you, this would be negative 2, 3. Interesting. This is the beginning and this is the beginning. What do you notice? It went up 2 units. negative 1, 1. It went up 2 units. 0, 4. It went up 2 units. It's still the same shape, but everything's up 2 units. Okay? So that's what I want you to see is what the effect is happening. What's happening to make it change. Okay? And I guess I should have graphed them all here. I didn't even see that, but I wanted you to see how it compares. So do this on your own time. Graph the points here, and you'll see that everything went left 2. But you've got to show me the points. Then show me everything right, and then show me everything up. Okay, so I'm expecting you to be able to do that. Now, if we look at this one, we know that it's a Y effect. Vertical translation, 2 units down. Straight shooter. So I'm going to go f of negative 2. Let me try and see if I can get, hold on, let me pause it and see if I can get another example of something. So I wanted you to be able to see the original, so I had to get the other packet. Okay, so if you look here, I go f of negative 2. F of negative 2 is 1. Minus 2 is negative 1. F of negative 1 is negative 1. Minus 2, negative 3. F of 0 is 2. Minus 2, 0. F of 1 is 1. Minus 2, negative 1. F of 2 is 3. Minus 2 is 1. F of 3 is 0, minus 2 is negative 2. And I'll graph it on this one so you can get a visual. Left 2, down 1. If you notice, instead of the original going up 2, it went down 2. Negative 1, negative 3. Look it, instead of being here, it's now down, which means this one will be here, which means this one will be here, which means this one will be here, and this one will be here. It makes the same shape, it just slid down 2. Take those and graph it right there. Okay? We're going to need this for the next page, so I'm going to turn the page. Okay. I'm going to erase this and look. All right. So now what's different is that this time it's still with the x. But we need to think about this one now. So what we're going to be doing this time is we're going to be going f of 2 times negative 1. 2 times negative 1 is negative 2. So this is really f of negative 2. F of negative 2 is 1. Then I'm going to take that negative 1/2. I'm going to plug it into the 2. Make that a little bit bigger so you can see it. Sorry about that. So half of 2 is 1, negative. So this is really f of negative 1. And if I come down here and I look, f of negative 1 is negative 1. Let me zoom out a little bit so we can see both. Okay? So now I go 0. Well, 2 times 0 is 0. So this is really f of 0, which is 2. 2 times 1/2 is 1. So this is really f of 1. F of 1 is 1. This is really 1. This is 1. 2 times 1 is 2. So this is really f of 2. And f of 2 is 3. And 3/2 of this is actually 3. And that's 0. So I want to show you because I'm going to graph it. So this means that it's negative 1, 1, negative 1/2, negative 1, 0, 2, 1/2, 1, 1, 3, and 1.5, 0. So if you look, I think I did okay. It almost looks like, it's like the same height, right? But it's like they squished it this way. When I'm squishing it this way, it's horizontal, okay? So that makes sense because it's with the 2. It's with the x. So you know it's horizontal. But it's almost like they squished it. Well, if they squished it, it's not a stretch, it's a compression. But if it's a compression, it's got to be less than 1. Well, remember on the previous page, when we were with the x, the plus 2 really went minus 2? Wasn't a straight shooter. So now, instead of it multiplying by 2, it's the reciprocal, which is 1/2. And if you look, this new pencil graph almost looks like it's half the size of the original black graph. So horizontal compression by a factor of 1/2. Which means if I was to look at this and that's all I was to look at, I know it's with the x, so it's horizontal. But when I look at the x, it's not a straight shooter. And since it's being multiplied, I do the reciprocal. The reciprocal of 1/2 just means flip it, means 2. So that means that it's now a stretch by a factor of 2. So let's see if that actually works out. Let me erase this. And then let's start. Okay, so what I'm doing is, let me lower this a little bit. Half of -4. So I'm going to go f of 1/2 times -4. Half of -4 is -2. What's the y value? 1. Half of -2 is -1. Y value, -1. F of 0 is still 0, 2. And it won't always be in this order, by the way. I know you're like, oh, as soon as I get the first two, I'll just copy. Make sure, because eventually it won't be in the same order. Half of 2 is 1. F of 1 is 1. Half of 4 is 2, 3. Half of 6 is 3. So watch me graph this on the original graph, because I think it's good to always see the comparison. So I go left 4, 1, 2, 3, 4, right 1. Left 2, down 1. 0, 2. 2, 1, 4, 3, and then 6, 3. Wait, I think I did something off. Wait, that's 0. Just kidding. 1, 2, 3, 4, 5, 6. So now when I look at it, man, I feel like it's the same height. Top and bottom is exactly the same, but I literally stretched it out, and it looks twice the distance. Well, if you double 3, it's 6. That's why it's a factor of 2. Okay. All right, and by the way, you need to graph it. I'm expecting you to graph it here and graph it here. I just want you to see the comparison. Okay, let's go to the next one. It's on the outside. If it's on the outside, I know it's a vertical. Vertical, and if it's with the y, it's a straight shooter. So vertical stretch by a factor of 2. Well, let's see if that's actually the case. So I'm going to lower this down. What I'm doing here is I'm figuring out what f of -2 is. F of -2 is 1, but then I have to go twice that. 1 times 2, 2. So I'm doing f of -1 is -1 times 2 is -2. F of 0 is 2 times 2 is 4. It's twice the y because we're stretching it, remember? F of 1 is 1 times 2 is 2. F of 2 is 3 times 2 is 6. F of 3 is 0 times anything is 0. So if I'm going to graph this now, and get all the eraser marks, left 2, up 2. Left 1, down 2. 0, 4. 1, 2. 2, 6, up here somewhere. And then 3, 0. So if you look, here's what's interesting, and I want you to see. The distance from X didn't change, but it stretched vertically, stretched by a factor of 2. So you're stretching it vertically. The X didn't change at all. It's just the Y changed. Okay? Make sure you graph it down here. All right, let's do the bottom ones. So remember, if it's with the Y, it's a straight shooter. Vertical, but it's not a stretch because it's less than 1. Compression by a factor of 1/2. So that means I go f of -2 is 1. But then I have to take half of that. So half of 1 is a half. F of -1 is -1, but I have to take half a -1, which is -1/2. F of 0 is 2. Half of 2 is 1. F of 1 is 1. Half of 1 is a half. F of 2 is 3. Half of 3 is 1.5 or 3/2. Whatever you want to write. F of 3 is 0 and half of nothing is still nothing. So now I'm going to erase this, and I want you to see if it's really a vertical compression, which means it should squish this way. Let's see. -2, 1/2. Interesting, it's lower. -1, -1/2. 0, 1. 1, 1/2. 2, 1.5. And 3, 0. So if you look, I think I'm off a little bit, but you get the idea. It's the same distance x-wise, but it got squished this way. It's shorter now. It's a vertical compression by a factor of 1/2. Okay? Make sure you graph it. Okay, I'm going to stop it and do the reflections in a second.